Hi, I'm Justin. I go to Gateway High School in San Francisco, and this is my main project for Bootstrap Engineering. It's a self-balancing robot, so it has two wheels, and it can balance on its own. It can move forwards, backwards, left, right, all with the push of a button on my app. So first I'll give you an overview of all the components on my robot. This blue board here is an Arduino Mega. It basically is like the brain of my robot. It's a microprocessor that controls all the other components. Next is my motor shield. Shields for Arduinos add to the functionality of Arduinos, and mine is a motor shield, so it allows me to connect two high torque motors that move the wheels, as you see down here. Next is an IMU, which stands for Internal Measurement Unit. It houses an accelerometer and a gyroscope. I'm using these to give me the angle that my robot is at. So it'll tell me the pitch, and depending on that pitch, I'll know how to move my wheels, like whether to move it forwards or backwards to make it balance. Next, I'll be talking about PID control. PID stands for Proportional, Integral, and Derivative. It's a way to basically get my robot to balance based on its current angle. So the PID takes the angle from my IMU and it processes it and puts it through an algorithm that tells my wheels whether to move forwards or backwards so that my robot stays upright. On the top of my robot is a battery, and that simply provides power for my IMU, motor shield, and Arduino. And that's how I got it to balance. So what I added next was a Bluetooth module, as you can see here. So it's just a simple USB Bluetooth dongle. I also have an app running on my phone, so I can turn on Bluetooth on my phone, and I can use this app to control my robot's movement. So I can move it forwards, backwards, left, and right. So I got that to move, and that was really good. But I noticed that when my robot went too fast, it would fall over because my motors wouldn't be able to catch up. So what I did was, I'm using these rotary encoders that are attached to both of my motors, and these basically calculate the distance that my robot has traveled. And since I can also calculate the time, the current time on my Arduino, I can calculate the speed of my robot. So now I have a code that says if the robot's going too fast, slow down, basically. And next I'll be giving you a demo. So here's a video of my robot balancing. I'm not touching it, and it has solar panels attached to it. Right now the solar panels are charging my battery, which is providing power to my Arduino. Now I'm going to demo the remote control for my robot. So right now I'm not pressing anything, it's staying still. And when I press forwards, I can move forwards, backwards. I can make it turn. I can make it turn the other way. Cool, that's my app. So you just saw how my robot can move forwards, backwards, left, and right with the control of my phone. And some challenges I faced making this project were getting it to balance. So that means tuning the PID values. Every time I changed the values, I would have to go to my computer and reprogram the robot and wait a minute for the code to upload. So to stop that from happening, I decided to use 3 potentiometers that each control the P, I, and D values of my PID control. Another thing I faced was trying to understand how to code and how the code that I used works. There was a lot of math involved, especially with the PID control, and the complementary filter. So I really needed to combine my math skills with my logic skills to really understand that piece of code. So these 6 weeks at Bluestamp have been really great. I've accomplished more than I ever could have imagined. I was at my school's robotics team before this, and I didn't learn nearly as much as I learned here at Bluestamp. So I really learned to be patient, I learned to be motivated, and I learned that learning by doing is really the best form of learning. So I have added some modifications to my robot. As you can see here, these are solar panels. So they fit on pretty nicely, just like that. And they power my battery so that I can be continuously running in the sun, and I would never have to charge this battery. Another modification I added was these sensors. These are ultrasonic sensors, and back here I have an IR sensor. So I'm planning to make my robot fully autonomous, so that means it can move forwards. It'll keep moving forwards until it hits an obstacle, and it'll turn away from that obstacle. And thanks for watching my video.